My name is Zach Klima, and I'm the founder and CEO of WaitTime. Now, what WaitTime does addresses probably one of the biggest problems in the world, which is lines and crowds of people. How annoying are lines? How annoying are crowds? They're everywhere. So over the past decade, we've developed the only patented artificial intelligence building system when it comes to addressing these crowds. So what I'm going to do right now is I'm going to show you our 4 algorithms when it comes to addressing massive crowds of people. The first algorithm is what you see on the screen behind me. This is called our queuing algorithm. So what we do is we mount cameras, any camera in the world. We mount directly over the top of lines that are unorganized. So what we do is we take that video stream, the RTSP stream, and we process that locally on an HPE server. And in real time, we're able to get this information on how many people are in line, how fast people are moving through line at very, very high volumes. So we don't track Bluetooth or cell phones or Wi-Fi or facial recognition. We are 100% anonymous, and we've developed our own pixel tracking artificial intelligence, which is what you see behind me. So this right here is at Miami Heat's arena. And so when it comes to that, imagine you're in line and you're waiting. Look at the screen below. This is at the Barclays Center, where you actually are waiting. You're seeing on a big screen. You're gonna wait in this line accurately for 10 to 12 minutes. But if there's a shorter line around the corner, it'll message the screen to say, go to your left, it's wide open, or go to your right, it's just 5 minutes. So this first algorithm called queuing is for unstructured lines. Now, when it comes to more of structured lines, this is our second algorithm called our stanchion algorithm. So think about retail stores, think about airports, security lines, etc., where they're actually controlled when you're standing in a stanchion. So what we do, it's a direct overhead view of the camera, just like the first one. And what we're doing is we're monitoring, if you see on the screen here, the average rate of service multiplied by the live number of people in line, averaged over every single person, 24 times per second. So what does that mean? That means that we can accurately and in a very granular way break down the anatomy of this line all in real time. This one right here is at the 49ers Levi Stadium, as a great example of that in real time. And that's number 2. Now, when you're less worried about lines and you're more so worried about counting people at very high volumes, this is our third algorithm called entry exit. So this one behind me, this is at the National Exhibition Centre in England. It's the biggest exhibition center in the UK, about 11 million square feet. They came to us and they said, we have to count how many people are entering and exiting all day long, every day, over each entryway to the exhibition hall. So what we do, as you see on the screen, is we mount the cameras over all the entryways, and we're counting bidirectionally how many people are entering and exiting all day long, every day. So what they do with this is they package this up and they sell this back to the trade show organizers. So this right here is all around high volume counting when it comes to very, very frequent areas with a lot of people. So think about shopping malls. Mall of America is a big client of ours. The NEC, and anywhere where you're trying to count people at very high volumes indiscriminately with very high accuracy, this is the algorithm that will accomplish that. And that's number 3. Now the fourth and final algorithm is called our massing algorithm. And this is when you have cameras that are not overhead like the first 3, but it's off to the side, so a Z-mounted camera. And what this does here is you're never going to be able to count accurately due to perspective. So what we do is we monitor how full the area is becoming, 30%, 35%, 40%, all in real time. So think about this one as more of a heat mapping algorithm, kind of the secret sauce of how a crowd grows in real time. This is the algorithm that will accomplish that, called our massing algorithm. Now, all these algorithms run on an HPE server on-prem. And when it comes to this, Intel, when it comes, we're Xeon, that's what we're optimized to run on. So One API, vTune, and Getty are some of the accelerators that we use to be the most efficient with our compute, which of course is 100% CPU or 0 GPU whatsoever. Now, the last part about WaitTime, which is kind of the cherry on top and kind of the reason why I started the company all those years ago, is guest experience. Where can I find the shortest line? What we do is we integrate with each of the venue's mobile experiences, as you see here, so guests are able to check that venue's mobile experience to see, hey, where are the lines? How long are the lines for the restroom, for the concession, for the gate? but we also integrate with each of the venues' IPTV, so digital signage. So as you navigate through an environment, you're able to be notified, do I make a right? Do I make a left? Do I go up or down? All in real time based off of the crowds. So in conclusion, it's the guest experience plus the operations and data, all enabled by our back-end AI that I walked you through, that make WaitTime the world leader in crowd management. Thank you.